Good morning, and thank you for taking the time to join us for today's webinar on bringing zero trust solutions to your enterprise applications. Leading today's session is Jason Gmitter, Senior Director of Solution Engineering at Pensando Systems. We are also joined today by Ryan Young, Vandis' Chief Technology Officer, who will participate in a Q&A and fireside chat with Jason. In October 2021, Aruba introduced the next evolution of switching architecture, the industry's first distributed services switch with Pensando, the Aruba CX10000 series switch, to deliver advanced scalable network and security services for the enterprise data centers. For those of you on today's webinar who are new to Vandis, Vandis and Aruba have had a close working partnership for over 15 years. We are a platinum level partner and have one of the largest Aruba certified engineering teams in the Northeast. Our team sits on the Aruba Advisory Council. We are excited to share this new solution with you today. Just a quick reminder before we begin, we are recording the presentation of today's session, so you have been muted upon arrival to the webinar. Please feel free to submit your questions at any time via the chat, and we will address them at the end of the webinar. We do have a couple of polling questions today. The polls will appear in the chat, so please have that open on the side of your screen. And lastly, just a quick reminder to visit our website, vandis.com/events, for a list of upcoming events that you might be interested in. And now I'll turn it over to Jason.
Good morning, everyone. My name is Jason Gmitter. I am with Pensando Systems. Ryan, I'm really looking forward to our chat this morning as I take you through the CX10K.
Likewise.
All right, let's get started. So when we think about modern data center security requirements, for a number of years, there's been a number of different solutions in the market around trying to address micro-segmentation or network zero trust. And it's a tremendous challenge because there's a number of different places or solutions in the market for enforcing. But the bigger part is how do you discover what that policy should be? So you basically need to see everything going on within your data center. What are the relationships? What are the communication patterns that are happening east, west, north, and south in your data center? And the premise for that is at the end of the day, we want to reduce our attack surface. If something gets compromised, how do we minimize what that particular hacker is trying to do, which is set up command and control, try to see things laterally, move around within the data center, try to find the crown jewels. And just as important is how do we stop the breach? How do we potentially prevent data from leaking out if someone is already inside your data center? So it's not a new problem. It's a problem that's been going on, and there's been a number of solutions in the market. Some have been deployed. I've yet to see a customer get to 100% completion in implementing a network zero trust policy. I'm seeing somewhere between 25–50%, but what I'm going to take you through today is the lessons we've learned over the years and what we've implemented inside the CX10K to help you get to a full completion of a network zero trust project if you've started in the past and it's stalled, or if you're looking to get started at ground zero. And Joanne, I know we have our first poll. Would you mind opening that up for the audience, please?
Yes, I've opened it up. All set.
Beautiful, thank you. All right, I have one hardware slide for the group, and then the rest of the conversation this morning is going to be focused around use cases and solutions. So what I'm introducing to you here is the Aruba CX10000. If you look over on the right-hand side, it looks a lot like an 8360. It's slightly different though. We've taken two of those 100 gig ports that you normally see with an 8360. You still get your 48 ports of 110, 25 gig, and we have 6 ports of 40 and 100 gig. Underneath the covers, it's a Trident 3 chipset powered by Aruba CX operating system. However, what you'll notice, what makes it unique in the industry is we have 2 Pensando ASICs. We call them distributed services modules. Each one of these ASICs has 400 gig of bandwidth connecting down to the Trident 3 chipset. This is what allows us to start to enable and distribute stateful services right at the top of the rack leaf switch. that you're traditionally deploying, whether it was Cisco, Arista, Aruba, Juniper for that matter. But what you're now getting is a platform where we can start taking things like stateful firewalling, not stateless ACLs, but a true stateful firewall, DDoS protection, IPsec hardware-based encryption, NAT services, layer 3, layer 4 load balancing services, and then telemetry services such as firewall logs, IPfix as another service that will be offloaded from Trident 3, but enabled on these particular ASICs that you see right here. Yellow, I just want to be transparent, are roadmap items. Hardware is capable, just software hasn't been delivered yet on it.
Hey, Jason,
yeah.
apologies for jumping in. Just a quick question for you. In terms of the ASICs and the data inspection, how are you offloading the data onto the ASICs? Is it all traffic goes through? Is it policy based? Can you walk me through that a little bit?
Yes, it's a great question, Ryan. So when a packet comes in one of these switch port panels, normally when you try to insert a service in your data centers today, it's an appliance, whether it's physical or virtual, and you're doing things like PBR or putting the default gateway on that firewall or doing VLAN stitching or routing to it or routing through it. They're complex, they're cumbersome, and sometimes it causes more challenges than what they're worth. We've made it really, really simple to inject this particular ASIC in the path of a packet entering the switch. It's as simple as defining a VRF and one or more VLANs within that VRF. And that is essentially what programs the Trident 3 chipset that says if a packet comes in one of these front panel ports, whether it's a host-facing port or an uplink, if you match on this VRF, this VLAN or VNI, if it's a VXLAN-based fabric, the first order of operation is to send that packet up to the DSM for stateful inspection or to generate a source or form of telemetry on that particular packet. It's that easy. And then if I want to stop redirecting, I remove the VLAN, I remove the VRF, and then everything is switched locally. Answer your question, Ryan?
Yeah, totally. Appreciate that. Thank you.
Cool. So hopefully your minds are wondering, okay, how is this particularly managed? What does Aruba CX do? What does Pensando do in this particular model? We understand the ASIC piece, and we really haven't broken the operational model here at all. What we've done is we've allowed Aruba CX, I love their CLI. I've spent 20 years at Cisco, my past job, and Aruba CX I found to be very, sat down my first time without a configuration guide, was able to get a VXLAN fabric up and running. But anything related to layer 2 switching, layer 3 routing, multi-protocol BGP, EVPN, VXLAN configuration, that's all owned and managed by Aruba tool sets, whether it's NetEdit via the CLI or Aruba Fabric Composer. Anytime a packet makes its way up across one of these 400 gig links up to the distributed services module is where the policy is provisioned by Pensando's Policy Services Manager. And we'll talk a little bit more how those two pieces work together, but that's essentially the management piece of this. So as we go forward, like I said, today we have what's shipping is a layer 3, layer 4 stateful firewall, DDoS protection on a per VLAN per network basis, and then a source of or form of telemetry as a firewall log or IPfix for any packet that crosses the face of this ASIC as well. So let me move on. As we go through the next couple of slides, I just want you to kind of visualize what we've done here is normally what we've seen with some customers is when they're trying to deploy east-west microsegmentation, there's a couple of approaches they've taken, whether it's trying to take a large modular firewall appliance, or they might do some sort of software-based approach, installing an agent or software at the hypervisor level. A good way to visualize this is taking the line cards out of a modular chassis and then distributing them to the top of the rack. So as we go through this, just think about instead of having to send a packet or a flow and all of its associated packets to the end of the road to a firewall appliance, now think of unplugging that line card from the sheet metal, and it now becomes that top of rack leaf function for you with embedded firewall function. But the most important part here is it's all centrally managed as well. So if you have 10 racks, 100 racks, multiple data centers, Now think the entrance point to your network or the exit point off of your network to your application has a stateful firewall in the path behind every switch port that provides connectivity into your data center fabric, all centrally managed through Aruba Fabric Composer. So like I promised, 1.5 slides on hardware. The remainder of the presentation and my conversation with Ryan is going to be focused around use cases and what we've been working with customers on and what problems we're helping them solve. So Joanne, would you mind, as we go through this, opening up poll number 2 for us, please?
Okay, it's launched.
All right, beautiful. So when we think about working with customers around migration paths, trying to introduce the Aruba CX10000, we've come up with 3 different approaches a customer can take. The first one is it's a pure network lifecycle refresh, whether we're taking a legacy data center and upgrading the infrastructure, or it's a net new greenfield environment. Obviously, network lifecycle is pretty straightforward. Now in the middle, we think about on option 2 is we've replaced the top of rack leaf switch with the Aruba CX10000, and you might already have a zone-based firewall configuration sitting on your firewall appliance or virtual firewall appliance. So one of the options you can do is start migrating that Fortinet, Palo Alto, Checkpoint, or Cisco zone-based firewall function off of a centralized appliance and moving that and distributing that to all of your top of rack leaf switches, so that function now sits right at the top of the rack. So we have a number of different scripts and tools that help you migrate that policy from third party into the language that the Aruba CX10000 ingests. And then thirdly is, depending on where you are as it relates to your journey around implementing a true network zero trust micro-segmentation strategy and implementation, is, like I mentioned earlier in the session, is first I need to understand what are the relationships in my data center. The last thing I want to do is implement a security policy that breaks something. I need to first understand what should be permitted. So there's tooling embedded in the solution that helps me understand the relationships between endpoints, the relationships between the applications. What is web talking to? What is the application tier talking to? What are the dependencies on my databases and shared services? We help you discover those dependencies, and then we help you build that policy. So you have a nice migration path of replacing my top of rack leaf switch, migrating my existing zone-based firewall policy, whether it's PCI type segmentation, and then allowing you to get into that low-level granular micro-segmentation to lock down east-west communication, literally down into the same VLAN, into the same port group.
Hey Jason, I'm gonna jump in for a second and ask you another question. So when I'm talking to customers about the CX10000, there's a very common question that is asked, and that really has to do with doing that first step of migration. Day one, do the policies have to be live, or can I do a rip and replace of my old top of rack gear, put it in, and then slowly start to turn on services?
Yeah, you're spot on there, Ryan. You can, like I mentioned, you can start off as a traditional top of rack leaf switch, and then you can start gradually migrating. As I mentioned before, how do I get a packet up to the DSM? It's first define the VRF, and then second define what VLANs do I want to start providing these stateful services on. So I can start to gradually migrate those network or VLANs over for redirection, and then what are the different stateful services I want. And then it gets, and what's nice about that as well is that can just be the learning phase as well, where I leveraging those firewall logs or IPFix as a source of telemetry to help me discover that policy. Or again, I might already know that policy and gradually migrate that over for those particular networks that I'm ready to enforce. And then for those things you're just not sure about yet, as I mentioned, the last thing you want to do is implement a firewall in the path that it breaks an application in a production environment. When you're ready, you truly have enough data that represents the relationships and dependencies your applications have in a data center, then you can start turning on those other networks for those stateful services in the path. So it's not a rip and replace. Everything's now statefully inspected. If you know the rules, great, knock yourself out. However, most of the customers I think you and I have worked with, Ryan, is they feel more comfortable going through a phased approach, and the tooling that we've embedded within the solution set allows you to do that.
Awesome, thanks.
Cool. So from an architectural deployment point of view, I wanted to highlight three particular use cases, not use cases, but we'll call them architectural deployments where we fit in. So on the left-hand side is in a campus approach. We've had customers come to us with this particular use case around, can we deploy the CX10K at the aggregation layer in a campus and implement that stateful firewall function at the aggregation layer? And the reason being is that CX10K is not a PoE-enabled switch, therefore typically not going to be deployed in your campus closet. But we can use it as an aggregation layer to provide stateful firewalling within VLANs or between VLANs. The second one is obviously around the true zero trust network segmentation in your traditional data centers. And it's two particular fabric deployments. Your traditional two-tier L2 at the leaf layer, all the way extended up to your aggregation layer, where your gateways are sitting at your aggregation layer. So 10Ks down at the leaf layer for providing that distributed stateful firewall function. And then when we think about the more current generation standards-based multi-protocol BGP, EVPN, VXLAN-based fabric, a hardware-based overlay, another scenario where the 10K can be deployed. And then on the far right, the last case is when you start looking, if you're a particular customer that might have multiple fabrics, multiple pods, or multiple data centers, being able to deploy the 10K at the top of rack in both of those environments as well. So the one thing I forgot to mention earlier, and I apologize, is performance. So each one, if we look down here at this VSX pair, and obviously we have two CX10Ks, each one of these 10Ks, if you remember, each ASIC had a 400 gig connection to the Trident ASIC. So each 10K provides up to 800 gig of firewall protection. Now, in a VSX pair, that's an active data plane, you have 1.6 terabit per second of firewall throughput in a VSX pair. Now think about what you would pay for that in a firewall appliance that's centralized. Now you have 1.6 terabit at the top of every rack leaf switch pair in a VSX switch pair. Tremendous performance without introducing any bottlenecks.
So Jason, one other question I've had regarding this slide is, say, 3 years ago, I started to make my data center migration and picked up, a Arista or a Cisco spine. Can the CX10K integrate with those architectures, or do I have to rip and replace the spine and the leaves to make this technology work?
Yeah, Ryan, another good question. And it's common, right? Cisco and Arista are typically deployed in many data centers. And when we started shipping in December, it's one of the first things we were working on is being able to integrate with third-party spines. So whether it's Cisco, Arista, Juniper, third-party spines, whether it's, again, your traditional L2 back-to-back VPC or MLAG or VSX, or a EVPN VXLAN standards-based fabric, interoperability is working just fine. So yeah, that's a critical point you brought up, Ryan. Without having to rip and replace the entire data center, I can mix the Aruba CX10K into third-party environments. And that includes if the spine is third-party, and there also might be third-party leafs that are not up for replacement, you can start to insert the CX10K and interoperate in a standards-based fabric.
Awesome, thanks.
Yeah, man. So what I want to talk to the group a little bit about is a couple of different approaches I've seen customers try to implement or use to implement some level of segmentation, whether it's macro-based segmentation or micro-based segmentation. So traditionally, we would see customers try to put in, take their edge firewall and, buy the larger, beefier firewall with more connections per second, greater firewall throughput. But there's a couple of challenges when we think about that, right? The first one is the tromboning that needs to happen from these two workloads. If we look in the lower left corner, this web tier wanting to do a database dip, we have to somehow get this packet over to a centralized firewall appliance, whether again it's physical or virtual. So one option is I can put the default gateway on that firewall appliance. I can do something like PBR, or I can route to it or route through it or do some sort of VLAN stitching. They're all complex scenarios on how to insert a firewall. And the number of times I've seen outages because of configuration mistakes, or more importantly, it becomes a performance bottleneck. It's chewing up too many connections per second. It just wasn't built for the number of the amount of east-west traffic that happens within our customers' data centers. And then obviously the cost as well. So what we are enabling you to do, and again, this is one scenario around customers leveraging firewall appliances, again, physical or virtual, as a way to segment their data center. And as I mentioned earlier, the idea of visualizing, taking these line cards out of a modular firewall chassis and now distributing that to the top of the rack. So whether that compute is x86, whether it's a power system or even an IBM mainframe, the one thing that is shared in the data center is the network fabric. And now, as I mentioned earlier, the entrance into the fabric or the exit point off of the fabric, there's now a stateful firewall function in the path, all centrally managed. So we've eliminated the tromboning. We've eliminated the additional cost, the complexity, and the potential outages now by distributing that function completely at the top of the rack. So now when we think about that, again, I touched on this a little bit earlier. One of the most critical pieces here is when we think about the concept of having a stateful firewall behind every one of our Tor switch ports, it has to be centrally managed. It has to be easy to manage. It's got to be able to integrate with third parties. Give me context about what the workloads are that are connecting to the fabric. Let me know what VMware knows about the VMs that are connecting. The same thing with Nutanix. A lot of the times when we think about microsegment in the data center, we talk about the data plane, but what about the control plane? Things like VM kernel or ILOs. Those things are just as important to protect. So Aruba Fabric Composer is that centralized orchestrator that allows us to understand what's connecting to the fabric, helping us generate that security policy if we're migrating policy from a third-party firewall or we're creating net new policy.
So, Jason, can I jump in with two questions for you here?
Yeah, please.
I'm gonna pick on Paolo because you've had them as your example firewall along the way. So, customer comes in, wants to migrate from using the edge firewall trombone use case that you showed up above, where you're essentially U-turning all the traffic through a firewall for inspection and moving it to the Pensando layer. How is that going to be a tough lift, or is there a way to kind of easily take those policies and start to move them down?
Yeah, it's a good point. So, like I was mentioning a little bit earlier before, the ease of being able to selectively choose what needs to be inspected. So I kind of look at it as I have brownfield policy, and for those firewall appliances as an example. Well, if I have that known firewall policy, and that's macro based or it could be zone based, then I can just literally go into Aruba Fabric Composer and say these VLANs I know the policy for, and then like I mentioned, we have a number of different scripts that can convert third-party firewall policy into what Aruba Fabric Composer can ingest. And that's easy. It's an extremely simple use case of migrating what you know. Now, the hard part is all the stuff I don't know about, those granular micro-segmentation policies. In my past career, I worked with Cisco on tetration as an example. It's an application dependency mapping. That's the hard part, is helping me discover what should be my zero trust policy. Other tools like Illumio or Guardicore. So for those harder use cases, I like to call it in that zero knowledge environment, we've embedded tooling within the platform that leverages the telemetry we generate, every packet that goes through. So again, we select a VRF, we select one or more VLANs, we can start learning about the flow log transactions that give us that map that helps us understand what each endpoint relies on in the data center. And then from that data, we can start to develop that zero trust policy. And I'll show a demo of that in a little bit as we go through. But again, you can start simple, migrating what you have instead of centralizing it, distributing that function and policy at the top of the rack. And then we help you out with the harder part of discovering what you don't know.
Okay, so going off the discovering what you don't know piece, we have a lot of customers who have leveraged products like VMware NSX or ACI, and there's a whole lot of discovering what you don't know.
Yeah.
But there's also when it comes time to actually do the microsegmentation portion of it, there's been a lot of complexity about identifying the application groups that all work together and then moving them into a new network space. How does Pensando simplify that in terms of in terms of the realm of security in the context of VMware?
Yeah, it's so Aruba Fabric Composer has an API integration with vCenter. And this is something I'll also show you briefly today, and then Joanne and I are working on a deeper demo in a few weeks, where we learn about the context of the workloads. We learn their VM names. We learn their VM tags that a VMware administrator might have assigned to those different workloads. Things like lifecycle is prod, lifecycle is dev, this is a web endpoint. Any metadata that represents the workload. And we'll even learn via that integration around VM kernels, which ones are for vSAN, vMotion, or a software-based VTech, right? Critical things you need to secure. And then we can use that metadata in context to create endpoint groups and then create rules and policy leveraging those groups. And the beautiful thing is we don't ask you to re-IP anything, because we're able to implement that stateful security policy inside of the VLAN. So if your web app and database tier all happen to sit inside the same subnet or broadcast domain, that's great. That's not a problem. We don't ask you to re-IP things and separate them into different networking groups or different VLANs so you can implement a security policy. So again, just really want to highlight the simplicity of being able to insert this and being as least disruptive as possible. And re-IPing things is extremely disruptive, as I'm sure all of you know.
Awesome. So it's really like a cloud-based networking in a way with object-based tagging.
That's absolutely correct. And I'll show you guys an example in just a few. There's two other things I wanted to highlight here. And maybe some of you are thinking this, yeah, I've seen this story before from a different switch vendor. There's three things that I think that truly differentiates us as it relates to how we solve this problem in hardware. The first one is TCAM. Right. When I was in my prior job, we would try to take discovered policy from a network or application dependency mapping tool, and we would try to squeeze that policy inside of a switch. And you know what would happen? We would blow out the TCAM on that switch. It just did not have enough space to hold a fine-grained policy. The second thing is stateless. Any L2, L3 switch today, they implement a stateless firewall. And the third thing is when I implement a security policy on an L2, L3 switch, it's a flat policy model. It's 5-tuple based. And those have been the challenges that we've been stuck with through the years, and we've solved all three of them. The first one is we don't rely on TCAM. We rely on high-speed extended memory embedded in the Pensando chip. We can hold up to 1 million rules per switch. It blows the doors off of any switch in the market today. The second thing is obviously we're stateful, not stateless. We generate a firewall log for every transaction, every flow. And then the third thing, Ryan, you touched on this just a moment ago, is we don't rely on just using 5 tuples to build rules and policy. If you want to use this source IP prefix, talk to this source IP prefix, knock yourself out. However, we also provide you the ability to build rules using those human readable names that we learned from vCenter or we learned from Nutanix or other third-party orchestrators. Let me use tags and metadata to define what are my groups of endpoints I want to wrap policy around. And then the last piece with that is we allow you to build hierarchical policy, which I'll talk about in the next couple of slides. And I think is very cool that this is something you can now do inside your data center fabric. So as I mentioned, everything's centrally administered, centrally orchestrated, and that includes the network bring up, whether it's just a simple L2, L3 fabric, or you're building a next generation VXLAN-based fabric, that can be all orchestrated through Aruba Fabric Composer. In addition, that security policy that you are migrating or building net new, coupled with all of the context you've learned through some of the partners listed above, that policy is centrally orchestrated and then distributed down to each of the top of the rack switches. So data plane stays direct. So let me take you through this. So whether or not we have two VMs sitting on the same physical host, a VMware environment, they're connected to the same distributed virtual switch, we need to insert a stateful firewall in the path, we can do that. Whether it's between workloads on different hosts, between different VLANs, between a virtual machine and a bare metal instance, we can insert ourselves. Whether it's a pod or a container, virtual machine, or a legacy database environment, what you've seen here is we've eliminated any tromboning. We have a direct firewall inline in the path with minimal latency added, 1.6 terabit per second of firewall capacity at every top of rack leaf switch that scales out horizontally every time I deploy another rack. And this enables me to address whether I want to do micro segmentation inside the same port group, inside the same VLAN, inside the same hypervisor. I want to go between intra VLAN if it's bare metal hosts that are sitting in the same VLAN, or I want to do macro-based segmentation where I want to inject firewall in between VLANs. We address this with ease and simplicity. And then if there are use cases where I also want to inject a third-party firewall, let's say today we do not provide L7 firewall functions. Is it something that we're thinking about doing on the roadmap perspective? Absolutely. Just being very transparent, today it's an L3, L4 stateful firewall. If you want to inject a third-party firewall for L7 inspection, we also enable you to do that as well. But for what I have seen throughout my career, for east-west segmentation, L3, L4 stateful is 99.9% of the time more than enough. It's when you see those north-south traffic flows is where you're seeing more of that L7 inspection. Now, the one thing I haven't talked about yet, but I think is really important is, like I said, I've been talking a lot about firewall appliances, whether physical or virtual, but obviously there's some solutions in the market that are software driven, whether it's a firewall at the hypervisor layer or you have a solution like Tetration, Illumio, or Guardicore, where the firewall policy and implementation and enforcement is handled by a software agent installed on the workload. And when I think about those software-based solutions, they do a really nice job of when you get the software installed. When I can get an application team to say, yes, of course, I'll install another sensor or an agent on my workload, which never happens. Or what about environments where, okay, maybe I have the software that's protecting the data plane where I get it installed, but what about the control plane? What's protecting the VM kernels? What's protecting things that I can't get the software installed? What about legacy operating systems where I can't upgrade them, but I'm not ready to sunset it yet? And this is where one of the polls talked about, if you have started a network zero trust project, how far did you get? 25%, 50%? So that other piece that has not been protected, I think, and again, if you've gone down the path of software, the CX10K can help you get that project to completion. So I can use that software where I have it instantiated. And now I can insert the CX10K as my top of rack leaf switch and now start protecting the control plane of my environment. I can protect things where I can't get the agent installed. If I have mainframes or power systems where it's unlikely they're going to have an agent or software to protect that particular operating system, well, that has to connect to the network somehow. Let me protect that. So whether it's a greenfield environment or you've already gone down the path, there are things that are still left unprotected in your data center. Well, everything needs network connectivity. And behind that network connectivity, you now have the option of saying you must go through a stateful firewall, whether or not you're going east-west within my data center.
So Jason, I have another jump-in question for you here.
Yeah.
So, over the past couple of years, we've seen a lot of malware that has been, attacking data centers, moving east-west, and one of the notorious ways of ensuring a payout is going after the SAN environment and actually encrypting the SAN so that recoveries can't be executed because they don't have access to that data either. And in talking about the solution with some of our customers, one of the big concerns is putting data replication across a firewall and whether the CX10K would impact that data replication and SAN to SAN traffic. What are your thoughts about the best way to protect large SAN infrastructure and can the CX10K handle it?
Yeah, it's a great question, Ryan, and that question comes up almost every customer call I have. And traditionally, when you've tried to put a firewall appliance in the path of storage traffic, whether it's backup, archive, IP-based storage, the firewall appliance ends up becoming that performance bottleneck, and it's connection per second bound that becomes a limiting factor, or it's bandwidth. And I remember back in this past December, we were working with a financial customer that had a firewall in the path, and it was crushing their Splunk environment. And it took weeks to identify it was the firewall that was causing this choke point. So this brings us exactly to your question. When you're able to, we're at 500,000 connections per second at a top of rack leaf switch. Unprecedented when you think about the price point and getting that many connections per second in a single switch. Then you're looking at 800 gig of firewall throughput, 1.6 when I put them together in an active-active scenario. I don't see any reason why, and we have customers that are testing and getting ready to deploy this particular use case that you brought up of being able to finally put something stateful protection in the path while protecting those storage devices and the IO that's moving between them. And critical points: latency extremely low, connection per second extremely high, and then the throughput is obviously there. And it's not just a single pair. Every time I deploy a pair of these switches and I scale this out horizontally, whether I'm pushing the 10Ks as close as possible to the source, or I'm putting the 10Ks at the top of the rack for where my storage might have, my centralized storage might be sitting, I'm scaling out performance every time I deploy another pair. So yes, short answer is you can absolutely put the 10K in the path of storage requirements.
Okay, cool. Thank you.
Yep. So the last piece I want to talk about, and then I'll touch briefly on management, and I'll show you a quick demo, is I think this is pretty cool. The ability to build hierarchical security policy in a network fabric. And as I mentioned earlier, normally it's a flat security policy that you put that you normally build on a switch. We have the term attachment points. Where can you attach policy to? So we give you two places to do that. The first is at the VRF layer. Every VLAN part of that VRF will adhere to that policy. We also allow you to apply policy at the network layer, the VLAN layer. So what you can do is things like down at the network policy or VLAN policy, I can do my low level, fine grained policy on what I can do inside the VLAN or between VLANs. And then at the VRF layer, I can do more of my higher level policy. So I can do things like prod can talk to prod, dev can talk to dev. Production can talk to shared services. Those are things I might want to do at the VRF layer as an example. And then down here at the network layer, I can have a network owner or an application owner come in and define their micro-segmentation policy. But this hierarchy, what it allows me to do is if a network or app owner tries to put in a rule set that says that workload A that's sitting in prod can communicate with workload B that still might be sitting in dev, it hasn't been promoted to production yet. Well, the network layer policy might approve it, but the security team's rule that sit at the VRF layer says prod can talk to prod. That would be a denied flow. We generate a flow log. That policy, this communication is not allowed. Typically something you would never be able to do or would be way too complex to do in a flat security policy. With this level of hierarchy, you can have different teams come in and apply their rules. And the other piece here is we allow, when we think about groups of endpoints, and again, as an example, when I worked on ACI back in the past, an endpoint, an IP could only belong to one group. It's a pretty rigid policy model. What we've done here is an IP can belong to more than one group, which allows us to implement that sort of hierarchy.
That is very cool.
Cool. All right, management, and then we'll get moving. So we've taken two approaches to management. Sometimes teams are still very segmented. So if the networking team wants to own any of the networking constructs of this environment, whether it's using CLI, NetEdit, Python scripts, Ansible, or Aruba Fabric Composer, we'll have those particular duties carved off for the networking team to carry out day in, day out. The day 0 bring up, the day 1 add moves and changes, the day 2 troubleshooting. Now, as it relates to the firewall function in these segmented operational duties, we have the policy services manager from Pensando. This is essentially which talks to the control plane of the ASICs, the Pensando ASICs embedded inside the CX10000. So whether or not you want to drop down into the user interface to build your security policy, or in large enterprises, I see less and less UI driven and more API driven. A enterprise can leverage the exposed RESTful APIs to provision firewall policy as well. So like I mentioned, two different teams will adhere to that particular operational model. Now, there are teams that we're starting to see that are merging. The term I commonly hear is NetSec, network security teams. So the policy services manager will always sit there as that quorum of 3 VMs that's pushing the policy down to each one of these ASICs that's sitting inside the CX10000. But now when we think about whether or not we want to consume that policy through Python, Ansible modules, but now we have those teams that are merging, that network security team. This is where Aruba Fabric Composer steps in, where we can orchestrate all of the network functions, get a very rich visibility about what's attaching to the network, whether it's Nutanix, VMware, control plane functions. And then also leveraging Aruba Fabric Composer as that single dashboard to orchestrate security policy as well. So you have some options around maintaining that segmentation and how you manage the environment, or start to go down the path of things being merged into one single team with roles-based access control. So I just want to do a quick time check. My apologies. I haven't seen my clock. I know I'm running a little bit late, but what I want to show you is a quick demo of a tool that's a little bit of a teaser for what we're going to do a little bit later on in June. So bear with me 1 second.
And while you launch your demo, I'll just remind everyone that you can type your questions in the chat panel, and we'll get to them at the end of the demo.
Cool. It'll be quick. My apologies for running late, Joanne. All right. So this is a tool we call the network dependency mapping, or network graph. So what it allows you to do is, again, the 10K generates a firewall log or flow log for every transaction the Pensando ASIC sees. So as an administrator, I can come in and I can decide, again, we say based on VRF and or network. So I can come in and say, I want to look at the flow logs within a particular VRF. I want to take out my microscope and look at the flow logs for a particular VRF. The next thing I can do is I want to create my user-defined groups. As an administrator, I know my web tier, my app tier, my database tier, my monitoring tier. I can manually create these, or I can dynamically learn them through Aruba Fabric Composer, or I can manually upload a CSV file that represents them. So what this now does is it further filters for me. So I'm looking at within pod 1, I'm only caring about my particular endpoints, and it's filtering down through tens of thousands or hundreds of thousands of flow logs to the unique flows that represent the endpoints I want to build policy for. So what it's going to show me is what are the unique flows that are happening based on the endpoints that I want to develop a network zero trust policy for. So you can see here in my demo environment, I have a set of source IPs that I care about. What are the destination ports they're communicating on, and how many times are those flows happening based on the time dimension that I'm looking at. So it allows me to continue to filter. I can go in and say, okay, now I want to look at my web tier, talking to my app tier. So it's going to, again, as you see on the right-hand side, it's further filtering those flows. And then I can pick what are the particular destination ports I care about. And then it shows me those relationships in a graphical way. And then from here, based on the directionality of those arrows, I can come in and use that to build my rules that say, this is what I want to allow the web tier to consume from the application tier, just as an example. And what we can do here as we're populating these new rules, we can add them to an existing policy that might already exist. It might already be applied, or we can add it to a new policy altogether. And what we're doing here is just another example. Now we need to focus on the app tier talking to the database tier. So we've embedded that network dependency mapping tool that allows you that zero knowledge environment without having to spend a fortune on the tool, being able to help me understand what's happening laterally in my data center and give me that graphical view that shows me what's happening east, west, left, right, and then build those rules and map them to policy, and then map those policies into a network or to a particular VRF environment. It's the hard part of network zero trust is what should the policy be when I don't know. And when we get together in a couple of weeks, we'll do a much further deeper dive demonstration on this environment, which will also include some demonstrations around Aruba Fabric Composer, as well as using context from vCenter and VMware to build those policies, VM names, tags, labels, VM kernels, and so forth. All right, Joanne, that's it for me as it relates to slides and demo.
All right, fantastic.
Jason, we have a question from the audience, and it really has to do with virtual machines. So, how is Pensando able to enforce policy between two VMs that reside on the same host?
Yes, great question. So that powerful integration between Aruba Fabric Composer and vCenter. So what we're able to do is AFC allows us to dynamically create a port group that's private VLAN backed. So there's a promiscuous VLAN, there's an isolated VLAN, and it's not a Aruba virtual switch, it's VMware's distributed virtual switch. There's no proprietary software that needs to be installed. We're just leveraging open APIs on vCenter. We'll create a port group that's PVLAN backed. We orchestrate the .1Q trunk between the 10Ks and the ESX host and the distributed virtual switch. And then we move those VMs into those port groups, or we're basically migrating an existing port group if it's a brownfield environment. That PVLAN function is what basically plumbs the traffic from that port group up to the 10K, up to the ASIC embedded inside the 10K, where we make a permit deny log decision. All of that is orchestrated behind the scenes, extremely simple. Does that answer his or her question?
Yes, okay. I think it does. Awesome. We have another question coming in, it looks like. You have a question in the chat that just came in that says, do you support migration of firewall rules from ForcePoint?
So literally, it's as simple as if you send us a sample config, we can update one of our tools. I have not seen one yet, but there's two folks on my team that focus on building these Python scripts that will take in third-party formats and convert it to our policy format. So if you guys can give us a sample, remove obviously your IPs that might be confidential information, and be more than happy to migrate that policy for you.